We're going to look now at average speed and average velocity. Now if we just jump into it, average speed is equal to the total distance travelled divided by the total time taken, where average velocity is the total distance travelled in a particular direction, and we know that as displacement over the total time taken. So average velocity is the total displacement over the total time taken. Okay, so we'll see how this varies then if we look at this example here. So you can see it says Mark walks 40 meters due east in a time of 190 seconds, and then he walks 100 meters due west in a time of 50 seconds. Calculate his average speed. So first of all, for the average speed, we need the total distance. So the total distance then is just equal to, he goes 400 meters one way, 100 meters the other way. That means he has gone 500 meters. His total time, he goes for 190 seconds, and then he goes for 50 seconds. So his total time is 240 seconds. So his average speed is equal to his total distance, 500, divided by his total time, which is 240, which to two decimal places is 2.08 meters per second. Okay, so that's his average speed. I'm just going to highlight that so we can refer to it. His average speed then was equal to 2.08, and we'll see if the average velocity is the same or not. So for the average velocity, we need the total time. We've already got that. We also need the total displacement. So the total displacement. Okay, now that's just how we think. He goes 400 meters east, which means 400 meters to the left basically, and then he goes back on himself by 100 meters west. That's 100 meters to the right. So basically his displacement from where he has started is 300 meters east. So that's where I've magically got this from, this 300 meters east, and I've put the east on as the direction is important for displacement. I'm going to rub out this wee diagram here, and then we can just finish this off. My total time is the same. Total time is the same as it was over here. So my average velocity is equal to my total displacement, which is 300 meters east. I'll just put that in, over my total time, which was 240. And if I did that on my calculator, I've just done that, I've got 1.25, and that's going to be meters per second, and you need to put the direction in as well, east, and that's it. So you can see distance, average speed and average velocity could be very different. Okay, just to give you one more example on this, if you imagine I went, just to make life easy for myself, I went 10 meters this way in, we'll just say 10 seconds, and I go another 10 meters this way in 10 seconds. My speed would be 20 meters over 20 seconds, so it would be 1 meter per second. Now, if I change this and I did 10 meters this way, and then I came back on myself by 10 meters, I'll do it underneath. Came back on myself by 10 meters. Then my total distance, I've done it at the same time. My velocity from where I have started, that's where I started, and I finished back in the same place. So my displacement is 0 meters, and it took me 20 seconds to do it. My velocity would actually be 0. My average velocity would be 0 meters per second.